In this video, I will describe the Prolog inductive debugger, which is on the way to creating Prolog algorithms with the manual neuronets, because it discovered a step using induction and pattern unfolding, which help to find Prolog programs using induction, which basically finds mathematical formulas from initial formulas, i.e. algorithms, which is the inputs to manual neuronets, and then the manual neuronet will optimize that algorithm using the induction and pattern unfolding, and that will, there is another repository which does the same thing. It was going to do the same thing, but it was called Starlog with an optimizer, but I think that it's probably easier just to put the optimizer into that repository. In fact, so anyway, Prolog inductive debugger is the debugger which finds errors in programs using these induction and program unfolding techniques. And the Prolog inductive debugger is a static analysis tool for Prolog programs that verifies whether predicates satisfy inductive properties. It checks 1. Base cases, 2. Inductive steps, 3. Termination, 4. Tail recursion, optional, and it can also generate proof traces to show how predicates execute, which I'm still working on, but apparently with the requirements it can do later. So installation, we have a way of installing it using Git, and then how it works. PID analyzes Prolog predicates using principles from induction. Base case analysis verifies that all recursive predicates have proper base cases. Inductive step analysis checks that recursive calls use structurally smaller inputs. Termination analysis combines base case and inductive step analysis to verify termination. Tail recursion analysis, optional, checks if recursive calls are in tail position. And bug detection identifies common issues in recursive predicates. So we have file structure pid.pl. It just has a list of the files, which is quite a few files here, such as, and we do things like main analysis, proof trace, bug detection, shell script for running the analyzer, and example Prolog file for testing. Example output code analyzing. Example output code and analyzing examples. Reverse.pl with options. Check tail recursion. Generate proof. Loading file examples. Reverse.pl found 2 predicates to analyze. Analyzing reverse 2 with 1 clauses. Found 0 base cases and 1 recursive case. And analyzing reverse ACK3 with 2 clauses, found 1 base case and 2 recursive cases. And then after it prints out that, it said Prolog inductive debugger report, predicate reverse 2, cross base case invalid, tick inductive step valid, cross termination invalid, cross tail recursion invalid, cross issues found, missing base case, non-terminating, non-tail recursive, and then predicate reverse ACK, which stands for accumulator 3, tick base case valid tick inductive step valid, tick termination valid, tick tail recursion valid, tick all checks pass, proof trace generated, use -- verbose to display end of report. So, and then it goes on, it sort of, where's what mentioned, it uses induction and pattern unfolding, and it says this simplified system can solve using pattern and induction and pattern unfolding bugs related to termination and those things, like correctness, tail recursion, missing base cases, structural errors, and what it can't solve: complexity, inefficiencies, non-structural bugs, any logic involving state I/O, numeric conditions or mutation, non-recursive algorithms such as fast Fourier transform matrix with which has mathematics in it and mathematical commutations, and matrix inversion for proofs involving algebra or arithmetic properties, and concurrency or side effects, so it can't detect race conditions, deadlocks, or I/O errors. And then there's some ideas actually came from ChatGPT, Dell and Claude, so there are some ideas what to call a repository in summary. And it does give the name Inductive Debugger down here, and then some test example, some commands to run the tests. Test a file using the options tail, proof, and verbose.